Yeah, if you add them, it doesn't work. If you subtract them, it doesn't work.
You create
It's
a
multiply.
Yeah, right. So this was the last strategy I told you about. Sometimes adding or subtracting them doesn't work either way. So I need to think, Matt, what's a new thing that I could do? Well, if I have equation 1 and equation 2 here, if adding and subtracting them isn't going to work, what I can think about is, what do I want this one to be?
2.
Yeah, I want it to be 2, right? Because then I could just subtract them as per normal. What I can do with that idea, just simply, is I can say, well, why don't I just take equation 2 and literally multiply by 2? That's it. I'll create a new equation. I'll take equation 2 and multiply by 2. If I have x times 2, what do I get?
Are you allowed to do that?
I am allowed to do that.
Yeah, so.
I'll get 2 of x. One second, let me just finish this off. What's negative 5y times 2?
Negative 5y.
What would that be? Negative 10y?
Yeah.
This one here, it's a little bit tricky, you just put in your calculator. Negative 17 times 2, what would that be?
Negative 34.
Negative 34, good. You had a question, Vince.
I did that, but then I thought like you had to multiply the equation 1 as well by 2.
You don't have to. You don't actually have to do that, right? Because you've got the equation that you want right here. Let's call it equation 3, right? So now if I take equation 1 and I stack it on top of each other,
Oh wait,
So you create,
yeah. What am I actually going to do now? Which ones do I want to subtract? I'll just take equation 3 and I'll subtract equation 1, just like how we're doing 3-digit addition and multiplication now. Remember, the idea with this is I want to eliminate the variables. How do I get rid of the 2x's here? I want to subtract them, right? Can you see that? If I subtract these variables, I'm going to eliminate that. If I create my new equation here, 2x minus 10y minus 34, that's my equation 3, and then I just take equation 3 and subtract equation 1, then I can do it as per normal, right? 2x minus 2x, what would that be? That would
0.
Good? Okay, be careful here. Minus 10 minus 3y? Or minus plus 3y? Good? And again, we've got another negative here, just want to be careful. Negative 34 minus 5 is going to be...
Negative 39.
Would it be plus 5?
So remember, what are you doing here? I'm doing equation 3 minus equation 1. So this minus that, yeah? Now here it's really easy to solve as per normal, right? You can just divide both sides by negative 13. Y equals to 3? I think that's good.
Yeah. How did you get y equals to 3?
If I divide both sides by negative 13, just put in your calculator. Negative 39 divided by, isn't that right?
No, it's right. Yeah,
I
it's
took the
right.
wrong way in the calculator.
And we can finish it off.
Somebody do that.
Plus.
I've got what y is equal to, so I just want to find what x is equal to. I'll sub into the other equation, right? Sub y equals to 3 into one of the other equations. Let's just do equation 1 maybe. That's an easier one, right?
Yes, do that.
So 2x plus, what's 3 times 2? That's just 9. And then you just want to rearrange as per normal, right? And then last step, divide both sides by 2. Okay. So that's how you can go from having an equation when adding and subtracting them together doesn't work. We had to create a new equation, and after that I got x and y through my solutions.